Hello, Year 10. Today we are doing a section called Further Transformations of Graphs. So we have already learnt the basic shape of the circle and the exponential and the hyperbola. Today we are going to move them around our Cartesian plane a little bit more. We can move them left and right and up and down. So let's find out how to do that. Starting with the circle, normally the basic circle is x squared plus y squared is equal to the radius squared. If you are going to move a circle off of the origin, then you will see it in bracket form like this. X minus h squared plus y minus k squared is equal to the radius squared. The center of the circle is the opposite number or opposite symbol to the one inside the bracket. So if it was a negative h, the x value will be the positive h. A negative k, the center will be at the positive k. And the radius is still r. Okay, so you can see one over here in the diagram. I had x minus 1 and y plus 1. So the center is at positive 1, negative 1. And then you count a radius of 3 in all directions from that center. For the exponential graph, the ones we've done so far were in the form y is equal to a to the power of x. So to move them sideways, you put a number in the power of your x. So this x minus h here, that is going to move left or right, and it will be the opposite of the number that's there. So if that was x minus 2, it'll be moving it to the positive 2 on the positive side. The number on the end is going to move up or down. Okay, so you can see the example there. If we have y to the power of, 2 to the power of x minus 1, and then plus 1 on the end, the x minus 1 means that my y-intercept, which is normally at a positive 1, will move sideways. Sorry, my y-intercept, which is normally at 1, will move sideways, but also the plus 1 on the end is moving my horizontal asymptote up to y is equal to 1. All right, the hyperbola. The hyperbola in basic form is y is equal to a over x, some number over x. By putting x minus h on the bottom, that is going to move left and right. Again, the opposite symbol with the number that's there. And the k is going to move it up or down. Positive numbers move up, negative numbers move down. So the best way to start with this one is with your asymptotes. So if we have x minus 2 on the bottom, that's going to move my vertical asymptote to x equals a plus 2. And the plus 1 on the end is going to move my horizontal asymptote up to y is equal to 1. And then you draw the rest of the hyperbola around it. So let's practice moving some of these graphs around. Here's example number 1. It says, sketch the following graphs, labeling the important features. The first one is a circle. X minus 3 in bracket squared plus y plus 2 in bracket squared is equal to 16. The center of that circle is going to be a positive 3 and a negative 2. The radius comes from the 16. You square root the 16 to get 4. Then that's enough information to draw your circle. So you need to make sure you draw a Cartesian plane big enough that you can show a radius of 4. 1, 2, 3, 4. And we're also starting a lot further along the origin, so I'm actually going to need to go up to 7 there. And Okay, plenty of space now. So starting with the centre, plot that first. The centre is 3 minus 2. Draw a dot. Then from the centre, you want to count 4 spaces up. 1, 2, 3, 4. Put a dot. 4 spaces down. 1, 2, 3, 4. Put a dot. 4 spaces left. 1, 2, 3, 4. Put a dot. And 4 spaces right. 1, 2, 3, 4. Put a dot. And carefully draw up your circle. Okay, then just to be clear, it is a good idea to put the coordinates of each of those 4 points around your circle. So that's 3, 2. This one was 7, negative 2. This one was 3, negative 6. This one was minus 1, minus 2. And the centre was at 3, minus 2. Okay, so that's how you draw a circle. Let's move on to part B. This is an exponential equation. So the x plus 1 in the power is going to move our graph left 1. The minus 3 on the end is going to move it down 3. So because it's an exponential graph, let's start with the asymptote. And my asymptote has been moved down 3 with the rest of the graph. The horizontal asymptote is normally at 0, so when I move it down 3, it's going to go 1, 2, 3. And my horizontal asymptote is now going through y equals negative 3. Okay, so from here, we probably want to sub in our x equals 0 and y equals 0 so that we can find our intercepts. So if we sub in when x equals 0, we would get y equals 2 to the power of 0 plus 1, which is 1, and then we have minus 3. 2 to the power of 1 is 2, minus 3 is negative 1. Okay, so my y-intercept is at negative 1. Let's put that there, label it. Then I'm going to find my x-intercept by subbing in that y is equal to 0. So that would be 0 equals 2 to the power of x plus 1 minus 3. Move the 3 over to the other side, so 2 to the power of x plus 1 equals 3. To solve that equation, I'm going to need to go to logarithms. So I'm going to slide my base, so it's x plus 1 is equal to log base 2 of 3. And then move the 1 over, would be log base 2 of 3 minus 1. However, to calculate that, I can't do a log base 2 on a normal calculator, so I'm going to need to do a change of base. I'm going to change it to a base 10, so it'll be log base 10 of 3 over log base 10 of 2, so that's the equivalent of the log base 2 of 3. I still have the minus 1 on the side. Now typing that in, we will have log of 3, close bracket, over log of 2, close bracket, minus 1. So 0.58 or even 0.6 is probably more accurate than I can do on this graph. So x equals 0.6. I'm going to mark that here. So 0.6 is that value. And my exponential is going to be coming up from there. There we go. All right. So there is my exponential graph. I have my y-intercept labelled, my x-intercept labelled, and my horizontal asymptote. So next page, we have got our hyperbola. So our hyperbola has been moved. The x plus 2 on the bottom means it's going to move to the left 2 spots. The plus 3 on the end means it's going to move up 3. And the best way to visualize that is to move your asymptotes. So drawing up my Cartesian plane, I have a few values on here to work with. So the horizontal asymptote, sorry, the vertical asymptote first has been moved left 2. So that means it's going to come down here through the x equals minus 2. So we put at the top of it, vertical asymptote at x equals minus 2. The horizontal asymptote has been moved up 3. So let's come across here horizontally, going through at x equals 3 and label it horizontal asymptote at y equals 3. Now I am going to find my intercepts. Because it's a positive hyperbola, I know that my hyperbola is going to be in the first and third quadrant, equivalent around those asymptotes, but I want to find some intercepts to go around it. So I'm going to sub in when x equals 0, which would be y is equal to 1 over 0 plus 2 is 2 plus 3, so that's equal to 3.5. Then I'm also going to sub in that y is equal to 0, which is 0 equals 1 over x plus 2 plus 3. Move the 3 over to the other side, which is 1 over x plus 2 is equal to minus 3, times the denominator up, so minus 3x plus 2. Expand the brackets, add the 6 to the other side, which makes 7, and then dividing by negative 3, we either get negative 7 over 3, or that's negative 2 1/3 if you want it as a mixed numeral. Okay, so let's put those on our graph. Y is equal to 3.5 would be about there, and then my hyperbola will be coming down through that and approaching my asymptotes from both directions. So let's put here, just labeling that point, that is 0, 3.5. Then my other intercept was at x equals minus 2 1/3, which would be about there. So my hyperbola is going to be coming down through that value, and I'm going to label that point, which is negative 2 1/3, 0. All right, so there's my hyperbola with asymptotes and labeled points. Question 2. Find the coordinates of the intersection of the graphs of these equations. So that means simultaneous equations. We're going to have equation 1 and equation 2. So we're going to sub equation 2 into equation 1. Subbing in, we're going to have x plus 3 equals 1 over x minus 2 plus 1. Then we're going to subtract the 1 from this side across. That will be x plus 2 equals 1 over x minus 2. Then times your denominator to the other side. So it'll be x plus 2 times x minus 2 is equal to 1. Expanding that out is a difference of 2 squares, so you'll have x squared minus 4 is equal to 1. Add the 4 to the other side, x squared equals 5, and then square rooting, we will get plus or minus 5, root 5. So that means I have two solutions. The first one is going to be a positive root 5 comma something, and the second one is going to be a negative root 5 comma something. The equations that I had, the easier one is the second equation, where it's x plus 3. Whatever the x value was, I add 3, so it's root 5 plus 3. And then for negative root 5, it'll be negative root 5 plus 3. And that's it. There's my points of intersection. Time for you to do 10K.